Hello. Hi, it's V. Deepika, working as an assistant professor in EC department from KG Reddy College of Engineering. Now, as already have explained about the rectifiers topic. Okay, I have explained about the half wave, full wave, and as well as the bridge rectifier output. But still, some of the ripples has been present in your bridge rectifier output as well as the full wave rectifier output. Okay, now to minimize the ripple means we are not achieving the pure DC in the case of your bridge rectifier. Okay, but our main target is on we need to convert the total alternating voltage into your pulsating DC voltage. Okay, so the to total pure DC form of voltage should be achieved, but I can't achieve by using filters, so I can achieve by the pure DC of voltage by using the filters and the regulators. Okay, now how will this happen? Let us discuss in clear detail. Okay, now we know that the pulsating DC waveform is the output of the rectifier circuit. Okay, see, in order to obtain that, we need to filter out the oscillations from the pulsating DC wave, okay, with the help of a diode capacitor combination. So this can be achieved. So the charging and the discharging of the input filter, we said that it fills the gaps between each peak values. Just see the circuit diagram. Here I have used one diode and the load resistor in the beginning of your rectifier. So now I will use one more capacitor. Okay, I'll use one capacitor at the output, so that this capacitor, we are having two types of filters, either capacitor filter nor inductor filter, but instead of going for inductor filter, most of us you will use this capacitor filter only, as it is efficient as compared to your inductor filter. So now just I am using one capacitor at the end of your diode. So what happens now, just the charging and the discharging of a capacitor is so that it fills in the gaps between each peak value. It means that what here, just see this when the initial charging of the capacitor, when it has been forward biased, when the diode has been forward biased, what happens, this capacitors will be charged at once when the power is turned on. Okay, Nama. Now the next, when the capacitor discharges through the load resistor of the peak of the positive alternation, means what, when negative half cycle has been given, what happens after the peak of the when the negative half cycle has been done, this capacitor, this diode will be in the reverse biased. So when the diode is in reverse biased, what happens, this stays at that voltage only. The capacitor will be staying in that position only. Okay, so from that position to till the next voltage has been applied, means next positive half cycle has been applied, means what, here from this peak value where it has been discharged, just see this compare here, when I am applying the positive half cycle, okay, the capacitor has been charged to its peak value. When the positive half cycle has been discharges, so what happened, the capacitor starts to discharge, depends upon your capacitor charging and discharging. So when the capacitor has been discharged, what happens, sorry, when the negative half cycle has been started, means when the positive peak voltage has been neglected, means has been coming down, the capacitor starts to discharge, so it remains in the same position. Is it right? So what happens, so it will be staying in that position still again when the input half cycle has been raising. Okay, so this is a circuit diagram when the capacitor discharges through the load resistor after peak of the positive alternation when the diode is reverse biased. So this discharging occurs during the portion of the input voltage indicated by the solid blue curve. Okay, now just see this one up till discharging we had seen. So up till T2, this one is T2 is where negative half cycle, from T1 to T2 period is nothing but your negative half cycle. Okay, from T1 to T2 it has been little bit slow, but it will be remaining same, it is that position only. Okay, now again from T2 onwards after 0.7 it has been started. So what happen again, the diode will be in, when the negative positive half cycle has been applied, the diode becomes forward biased. When the diode becomes forward biased, what happens, the capacitor again starts recharging, start charging, so again it will shift upwards. Okay, so like that, during by using the capacitor, so we can't directly shift the output current to 0. We can maintain at your almost at, like if you think this one is positive half cycle is of 5 volts, you can maintain at least it up till 4.7 or 4.5 volts. Okay, so it will not directly jump to 0 by using this capacitors. Okay, now we know that performance of a full wave rectifier over a half wave is much good, is it right? So but when the time between peaks is shorter, okay, the capacitor can be more effectively reduce the ripple. So if this time period t1 to t2 and 0 to time period is less, then what happens, the capacitor also can be more effectively reduces ripple. Okay, these are nothing but your ripples. So the same slope means the capacitor discharge rate. This is the case of your half wave, and this is the case of your full wave. Why? Because in the case of the full wave output, we will be getting the positive half cycle for your negative half cycle when it is applied also. So here what happens, the ripple contents will be less. Okay, Nama. Now we are having one doubt that, okay, now the capacitor here appears as a short circuit while charging. This will leads to a, what happens, large current flow through the diodes. Okay, now this I have taken with respect to a bridge rectifier. Okay, now either if you go for your half wave rectifier or full wave rectifier, as this capacitor acts as a short circuit while charging, a large current flow would be flown through your diodes. What happen, so it will be damaging the device. Okay, now so to avoid the damage, okay, some rudge resistor, some resistor would be used one between the end point of your diodes connection and here this capacitor value to avoid the damaging of the device. Okay, so this surge resistor value is also very low as compared to this load resistor what been be used. So to avoid the large current flow through the diodes, okay, if there is a large current flow, that there will be a damage in this diodes. To avoid that one, we must use compulsory one surge resistor where this value should be very less compared to your the load resistor. Okay, so this one is also mandatory. Okay, now this voltage regulation can be measured by the two means, like line regulation as well as the load regulation. For a given change in the input voltage, like how much change occurs in the output voltage, it's nothing but line regulation. Okay, it's nothing but change in of the output voltage by change in input voltage into 100%. Okay, in comparison to your load regulation, the rate of output voltage change over a certain range of current values means what, if you take the minimum current means with no load voltage to the maximum current means if when you are applying full load voltage, it is nothing but gives your load regulation. So VNL minus VFL by VFL into 100. Mostly in your rectifiers we need to calculate the load regulation by connecting without load and by connecting with load, and we must get the values of no load voltage and full load voltage and calculate that load regulation in the case of your full wave and as well as half wave as well as bridge rectifier. Okay, so that we can estimate the regulations, okay, how much it has been regulated. Okay, now we are having one doubt. Okay, I'll just ask one new question that, okay, we can achieve almost nearly to the pure form of DC. Did we achieve the pure form of DC in this case or not, in the case by using this filter? Please. Please think, students. Did we achieve the pure form of DC by using this capacitor at the output? Okay, better. Okay, now let us, we did not achieve pure form of DC by connecting the still the capacitor the output of your this diodes and the load resistor value. Okay, some little bit ripples have been content in the output. Okay, Nama. So what happened, we have used this IC now we can, so normally let us think that transformer, while giving to just see this regulator power supply. Now first one we are using some transformer to step down the turns ratio, and next we are using one diode or two diodes which acts as a filter rectifier to convert this voltage into the like only positive half cycles to be at the output, whereas we are using filter, okay, to get the less ripple factor, means to achieve mostly at the above, means to maintain to get the 100%, but in the filter also I can't achieve the pure DC waveform. Some little bit of ripple contents have been still in the filtered output. Okay, now just see this, this is the transformer output and the rectifier output is nothing but this one. The filter output we have got achieved this filter output, but we need to achieve this type of output, pure DC form of output. Okay, so to achieve this pure DC form of output, still one more circuit need to be fixed at the output of the filter. Okay, so that is nothing but we need to use one more regulator at the output of the filter to achieve this pure form of DC. Okay, Nama, that we will give to the load and we will see this output. Okay, now for that simple we can use the Zener diode voltage regulator. By using Zener diode we can achieve this pure DC waveform of voltage. Okay, like this Zener diode voltage regulator, it's based on the particular characteristics of the Zener diodes. Like when the Zener diode has been operated in the breakdown region or the Zener region, the voltage across it is substantially constant for a large um, change in of the current through it. It means like what? Like the Zener diode is used in its reverse bias region, as already you all know. Under the reverse bias condition, the current through the diode is very small, of the order of few microamperes. So when the sufficient reverse bias is applied, the electrical breakdown of the Zener diode occurs. So the large current flows through the Zener diode, such as a breakdown occurs at a voltage called the breakdown voltage. So under this condition, whatever may be the current, the voltage across the Zener is constant, which is equal to Vz. So this large current due to breakdown is limited by connecting this resistance in the circuit. So as the voltage across the Zener diode remains constant equal to Vz, it is connected across the load and hence the load voltage is equal to the Zener voltage Vz. So this Zener diode acts as an ideal voltage source which maintains a constant load voltage independent of the current. Okay, so by using this Zener diode voltage regulator at this one, we can achieve the pure form of DC. So have completed by this using this, so connection this regulator power supply block diagram. By using this RPS, we can completely convert the alternating voltage into the pure form of DC voltage. Okay. Okay, ma. Now in the next session, let us discuss about the biasing. Okay. Thank you.